So, hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 150 and in this video we continue with our repetition of the keywords. And of course we are not just repeating the keywords, we are extending our knowledge, and like all time I will use the website of cppreference.com here so that we learn to use documentations, but our goal is still the official C++ documentation, to understand it so that we can all time search informations in the official documentation so that we have not to ask anyone, and that's our primary goal. And of course to understand all the structures and things in C++. And the next thing is here, like all time I will read here a question. You should pause the video and try to answer it as good as you can, and then you can continue the video and compare it with my answers. My answers will be not perfect because this is a practical video. A practical video means I can't write all the answers here down, but instead of writing all the answers down, I will indicate the answers here and I will refer to the site where you can read the right answers, but I will try answer them as well. So, and with that said, we can start. And the first thing is what we do here is number 64. It says here, what is a keyword? And we have here blow, throw, show, no, low, high, and attitude. So this is our first, and then you should explain the syntax of the keyword which you found, or if you have found any, then why we need it, and write an example code. All right, this is our first task. Pause the video, try it as good as you can. And I, of course, will not pause the video, I will just go on. So, first, what is a keyword? I hope you get it. It was the word throw. Throw is a keyword. All right, the second, explain the syntax. And when you see something like that, explain the syntax means if you memorize it, very nice, but you don't have to memorize something like that. Just go to the official documentation and try to explain it here, because this is the start goal which you should know. So we go here to the word throw, we click on it, and you can see we have here different options, and in our case we will talk about this throw exception, but here a very fast word about these two other things which we are not talking about now, but I mentioned it something here, and we are talking about this green things here. It says here until say 17, which means this here, these dynamic exception specifiers are not more supported. So when I click on it, for example here, and then you can read here this throw, it's exactly what we will talk here in a moment, but this throw is a little bit different, which means we have here round brackets, here round brackets, and important is that this here is deprecated in C11 and removed in C17. Which means it is not used anymore. So the question is then, okay, when it's not used anymore, why they show it us here? And the question, this is a nice question and you have to know it. The answer is only because it is not used anymore. You have to know it because there are many codes which was written before this time here, when they was removed or something like that, which means you will find many codes which use this specifiers or this version of the syntax, and you have to understand it as a programmer. But this kind of stuff you make later. What I mean with later is now we are starters. We try to learn first the normal keywords which are right now used, and later in intermediate you should learn other things too. Because only, like I said, only because it's not used nowadays means not you have, still means you have to learn it, because to understand the code which was written before, yes, like here, before C20 or C70, and that's the reason. That's bad news, but yes. that's for, let's say you can skip this for intermediate users and more advanced. We are starters, so we don't care about this one, at least at the start point right now not, which means in our case we go here to the throw expression, and here in the throw expression is our syntax. So, and we can go back and answer this question. It says here explain the syntax, and you see the throw expression syntax here is actually very simple. We have only two, but careful, these two are different, have different meanings, and we have to talk about this one. And the good thing is we can talk fast about it. It starts with throw, and like all time, this black color you have to use here, and expression you have to find it what an expression is. And here one word about this expression again, because you see this expression comes so often in this documentation. It's a good idea that you really look after this one. And here I already opened this one here. It is here expressions, and here is a lot of explanations. You can read them through, but in our case I will skip this. You can do this. And the important sentence here is perhaps for us this sentence here. Let's read this one here and skip all the other ones. You can read them offline. It says here, each C++ expression is characterized by two independent properties, a type and a value category. Okay, this is still very, let's say, not clear what this really is, but the important part is you should think about an expression. It will have all time a type, and that is very important for us. Of course, it will have also all time a value category. So think about it. Any expression will have a type, so we can ask for the type and we can ask for the value category. Then we know it is an expression. Still very not clear. We need many examples to understand this very well. But here with this one, you should start and then check all what expressions are and something like that. For example, here they made here, said here, an expression is a sequence of operators and their operands, for example. And in this case, they made just a here an addition example. The operand would be this one here, the 2 and 2, and the operator would be our plus. And like it says, the specifies a computation. Yes, this one specifies computation, but like I said, you should start with this sentence here, which means this expression should have a type. Yes, this will have a type after it's finished. And a value category, yes, it will have a value category. This one is very simple. There are other expressions like this one. This one is also an expression. It's a little bit more difficult to see what's the type and the value category. And yeah, you need a little bit training there, but that's for expression. And like you can see, it says here throws as an expression. And a very simple expression would be just the number 1. It's also an expression because 1 is has a type and has a value. And later this throw, you can see the second syntax here. We will talk about this shortly because this has another meaning. And no, I mean, we will talk about this very, very long actually with an example. But in this video, we talk short about this one and we will not go into this one. We go first into this first syntax here. So, and yeah, so expression is this one here. Oops, not this one, this is statement. Expression is this one here. You should know what an expression is and put it in. And you see syntax very easy. All right, I talk too much and explain the syntax. I hope this one is okay. We need just a throw and then an expression. All right, why we need it? Why we need it? What do you think? The answer is to indicate that I write it not the right answer, just to a random answer, which still is okay, but later I show you the right answer, to indicate that an error occurred and we have, oops, we have to solve it. Or something like that, right? And the official answer would be when you go here to throw here, the first line is the official answer. It says signals an erroneous condition, right? And executes an error handler. What does this mean in particular? I will make later an example and then you will see. And this answer is similar, but the other one is better. Okay. Let's go. This one is okay. And write an example code. So when you see something like this one, when I ask for write an example code, you should all time try to take the syntax, copy it, and then write an example code with the syntax. Because if you make it this way, I mean, if you have memorized it, you can use your memorized idea. But if you make it with the syntax, then you train also the syntax a little bit. And we are starters, we should train a little bit the syntax. I mean, you don't need to use the syntax all the time when you already know it. And I have here some other things which I delete now, because now what I'm doing is I write here the syntax. Here I write, oops, I copy it here. This is our syntax, which I copied just from here. And now I write with the syntax an example code, because this should work, right? This is the meaning of using a syntax. So let's use it. So I write here throw, and now I have to find an expression, and I said an expression you should learn a little bit what an expression is. But important is when you know this one, it needs a type and a value category, and one very easy example is 1, for example. This one here is actually, when we think about it, not a type, right? It can be converted to a type, but it is not a type, this one. What is this one again? We have not talked about this. It is just a literal. A literal means it is just a number which we choose. It has no, it's not an L value, which means it is not saved in a specific portion which we can use again. This is just randomly created. But important is here, this here can be converted to a type. And how I can see this, look what I do. I go here, I hover over it, and you can see this tooltip. This one here is considered here now as an int. Look what happens if I make here a .0. Now I save this and I hover my mouse over it, and you can see this 1.0 is considered as a double type here this time. And if I want to make a float type, I write here just a F, I hover it, and now it is a float type. So I have here an expression which has a type and a value. It's the value which you can see here. It's all time 1. If I want another value, I write here, for example, a 5. Now I have a value float with 50 value. And that means this one, a type and a value. But this one is very easy. Let's make a little bit more complicated type, which is, for example, as the string, let's see, as it is string. Can I do this? No, not this one, but let's make it easier. Not as it is string, let's make it here coder. This one here is also a type. We have not talked about, I mean, we have talked about this one here normally, but we have not talked about how the compiler sees this one. We have called this one a string, right? And the problem is the compiler, you can call, let's say, you can represent a string in another way. And when I hover over it, and you see a string can be represented as a const char, and we have not talked about it. In this case, it's a const char array with 6 elements. And we have not talked about this, but don't worry, this one is also a string, but this type here is const char 6 array of 6 elements. And I will not go into this one, so I will make it not too complicated. Just think this is still a string, and this is just another representation of a string. Right now, later when we learn why we can convert a string to a const char, then you will understand this one as well. But right now it is just a string, and let's make it easy. and use this one here to number 1. And we learned this one is now when I hover over it, the number 1 is the type int and the value 1. So next question is, does this code, this is my example code. Now I used here, let's go back to our syntax. I used the syntax here, and you can see here is the syntax, and here I used it. And the next question is, can I start it? And does this work now? What do you think? When I start here, the compiler, will this give me an error, or will this work? Is this, so the question is this syntax here right? Or let's say not so. The syntax is probably right, but is that what I wrote here right or wrong? What do you think? Say yes or no. There is not a big deal. And I started now. Let's see. And it makes bang. It makes a big bang, and it says exception unhandled. So what did you say? Did you say yes or no? Because it's very important. So the answer is this syntax is right. And if you are wondering why I say the syntax is right, even it shows me here an exception, then you don't know what throw means. And we are going to learn this. Because why is this exception right? Even the compiler is complaining that, let's start again and show again. So I start again, and the compiler stops this program. It is complaining that we have an exception unhandled. And the syntax is here right, because this throw is exactly throwing this kind of stuff. So this throw, let's go back to throw. It says here, this here, let's use this explanation here. The also throw expression signals an erroneous condition. So this one says we have now an error condition here, and executes an error handler, and this part we have not, but this part we have. It signals an error condition, and the signal of an error condition, it is doing exactly with this box which you can see here. It says here exception unhandled. Okay, that means just that we have not react to this exception. But the point is, this one is absolutely expected. It should throw an exception, and this one is this exception. The only problem here is we should react to this exception. So with other words, in short, this code is right, but we have to follow up with yes, the exception handler. We have the exception handler not here. So that was a little bit a tricky question, and if you say wrong is also right, I would say, because if you say wrong because there is no, it's a missing exception handler, it's, let's say it's not absolute right, but it's also not absolute wrong, because then you are just focusing more that we have wrote also the handler. Like, let me show you this one. Then you mentioned that we have also to use this handler here. But the code itself, it's right. The syntax is right. You can write it here. But of course, later we should react to this code and not just indicate this code. All right, let's continue. I think you get it. And if not, no worry. There are different solutions. So I wrote an example code. I finished this one here. And one word to this throw here, the second syntax. I will not talk much about it, but this throw has a meaning of we are throwing this error condition again. It is more a rethrow here than this one here, because here we are throwing this error, but we expect here, let's say a handler. In this case, we expect not directly a handler here. We throw it, we expect a handler, but later. And that's why we will talk about this also later, not now. We are talking just about this one. So let's go to the next question. So I confused you more than I have to. Let's go here to the 65. it says here, what is an exception object? Write an example. Okay, this is wrong here. I don't know why I have it here. Sorry for this one here. We skip this because this should be not here. Oh, perhaps it should be. I'm not sure. Anyway, let's see. Let's see. I'm not sure, but why it is here an exception object. All right, anyway, let's try it and see what happens. Okay, it says here, what is an exception object? It sounds very strange. If you don't know this, no worry. It has something to do, again, with our throw and this exception object. You will see it in a moment when I solve it. Try it, just try it. Write an example. Okay, and then explain this code. So this one, let's make this short here because I'm a little bit irritated that I'm asking it here. I wanted to ask this one probably later because it's not so, at least this one is not. Let's see. Try. I hope you tried it as good as you can. Perhaps you searched a little bit on the net. That would be nice. If not, no worry. It's not too difficult. I was just irritated here. So first here, what is an exception object? When we go here to the throw side, we are still in our throw exception, and when you scroll down, we have here two big blocks. The first big block is this exception object, and I will not read it now here through. You can read it, but the exception object here is more or less our expression. And I think I will just leave it with this one, which means this expression here will be used later for for execution and error handler. We need this expression here for this error handler later, and they call this one exception object here in our case. And here it says again the type of the exception object is the static type of the expression here, with and all the other things you can read, but more or less what they say is just think about it. This expression is our expression object, and read a little bit more. So the first one, I say it just is our expression. Let's write here expression, so to make it short. Write an example. So actually I don't need to write an example because I explained you the syntax here, right? I said we need throw, we need an expression, and our expression object is our expression, which means I wrote already here an example, and that means our expression object is this one. But what this expression object actually is, I explain later, because that's a little bit more important and a little bit more long. So let's go there and go on. All right, so write an example code. Yes, I wrote one already here on top. It's the same. And now we have to explain this code. This code, what you can see here, is a little bit difficult, but it is exactly the same what I copied here from this place. And you can skip the main part. Don't worry about this one. We just concentrate us on this part and try to understand it. You can pause the video and try to understand this little code here, because this code what I have here is exactly the same like here. And the problem here is a little bit, we have some parts not discussed, and I say you the parts which we have not discussed. First of all, this number presentation we have not discussed. We will discuss it in a moment when I explain it. And we have not really discussed about this STD overflow error code. But think about this. This is just a type. Think about this one. Just ignore all what this is. It is just a type, right? But we learned how to find this type. For example, this STD overflow error, or what this is here we have a resolution operator, which means it will search in our standard namespace. We know std is a namespace resolution order, and the namespace has this overflow error anywhere. So, and the other things you should be able to understand, and you can try it. I hope you tried it, because now I'm going to solve this function. And yeah, what we can do is, now I get this one here and I jump to my coding section. So I have now a code. I put it here on top. Why I'm putting here on top? Because then I don't need a forward declaration if I would put it down, and I can't put it in another function. And now I'm going to explain this function here. So what we have here is we have a return type which is double. The function name is f, and we have parameters with a double, and the parameter name is d. So then we have our function body here, and now it becomes interesting. First of all, because this has a return type, we need first the return value, yes. And now the question before I go on, what is that? The whole block here. Don't worry if you don't understand this one and this one, but the whole block here you should understand, and I give you a tip here. Think about this question mark. This question mark comes only in certain places, and we saw this already. I think I explained this one time, at least one time. And what is it? It is a ternary operator, which means it's a shortcut, or similar to a if statement, but in a short form, which means here we have a question mark, and here we have a colon, and then in front of the question mark we have the question, and it will ask if this what is in front is true or false, and depends on true or false it will react after the question mark, which is in front of the colon it is the true statement, and after this colon it will be the false statement, which means if this one is true it will react to this one. If this one here is false, it will react to D. So, and let's dive a little bit more into this one and start from start. So D is our parameter. We take it from here and use it as a return. We will return what? Let's start here. What we will return? We will return a value which is a double. So we need a double because the function return type is double, so we expect that this one should return a double, right? That's very important here. That's why I highlighted so. And now let's get started again here. D means here our parameter. Then we compare our D, which is a double, with a greater sign, and this one is a number. We have not talked about this number presentation now. If you don't know this number presentation, let me show you what it means. Of course, you have to look online again in online documentation or a good C++ book what this presentation means. But in short, all time when you read 1 and this E here, then you have just to replace this E with a 10 and write the 7 in exponent. And then you get this number here, which means you start with 1, then multiply it by this E. You replace with 10, and then you make an exponent 7. So this is just a shortcut for, let me show you this here in our online calculator. And I said what you are going to do again. Let me show you this one here. So we have here again this 1. I write a 1, then you see this E. E means multiplied by 10, so I multiply it by 10, and E means also exponent by 7. So which also it's not the right explanation, it's just a shortcut explanation, so you can use it directly in the calculator. The right explanation you should watch online. So let's go on again. 1 multiplied 10 and 7 is my exponent, which means I make here an exponent here, and then I write here the 7 in, so here. And this is the number actually what I have. So all time when you see something like that, e means multiplied by 10x, and then exponent is after the e, which you write in the exponent. Here an example, another example. When we see this number here, how you write this one in, how you would, what is this number here? The same like here actually. You start with 1, then you multiply by 10 because you see a e, and write an exponent, this 10 here, which means you would write something like 1 multiplied by 10 exponent 10 in this case. Oops, not 0 what I did. So here again with something like so. This time I did it right. This number here is this number here, and you can see they use this format of representation to avoid this typing. They don't want types a so long number. Instead they are just using this short version. It's easier to use in programs. So we have not talked about this, but I hope you watch this. And the easiest way is, I think one of the easiest ways how I explained it, just replace e with a 10, so multiplied by 10, and the other one is your exponent all time when you see it. So with that said, let's go back to our ternary operator, and the first part is our condition, which becomes true or false, because we have here a comparison operator, which means I compare d, which is our input. Here we have no input because I watch only the function here, but the d will come from here and it will compare it with this number here, and we can see, and by the way, if you hover your mouse over it, you can see here the number as well. Just in case you don't know it, but this number is a little bit hard to tell. It's easier to tell with this notation, that's why they use it. Okay, with that said, if this is true, it will become this one. If it's false, it will become d. So now, after I explained this a little bit, there is a error. Let's say not an error, there is something strange here. What you probably don't know as a starter. And think about it, what is strange here? I have not talked about this true section. Let me talk here a little bit more. So here we are using our throw statement, and you can see in my example here, I throw it just so, and they used it here in a ternary operator. And because this one is also any statement, we can use it here. But important is something else. Watch this again. And here is something strange. Think about this return value, and think about this line here. What is strange about that one? Think about a little bit. If you find something strange, then that's good. If you don't find something strange, which means you already know the answer, that's also good. So I solve it. The strange thing is here, this is a function with a return type. If this one becomes false, it's d. D is a return type, right? This is this one here. It will just return that what was inputted here. That's okay. But the strange thing is, what is if this is true, which means it jumps in this place here, or let's say it jumps not, it execute this part here, and we have a throw here, but what is the return type about this throw? And we will learn this later, because this one is very important to know, and I will show you later that, but I say you the answer. First of all, here we have no return type, and the reason for that is it will not jump to this place here. And the explanation I will give you later, just so that you know it. This is something special. It's not the normal flow of the program, and that's why we have to discuss a little bit more about this throw. But like I said, later, because we need to know a little bit more about the next question probably. Let's see, what was it here? this one, or exception object, was easy. Write an example. We did explain this code. I just cut it out and throw it down. That was perhaps not the best thing what I could do. Let's copy this one. I should copy it down, not cut it down, but it's late and I'm sleepy. No, no, that's okay. And here, comment this out. All right, this one works. Okay, we explained this code a little bit, but we will dive into this one a little bit more. So let's go on. And one more thing here, perhaps. Of course, you can go and try the combination with this one if you know it. But we will talk about this one in a moment anyway. So this D here, by the way, here you can see they are using it here, this function call, and they are putting in this other number, and we talked about this number. You have just to take 1 multiplied by 10 exponent 10, then you have this one. And the nice thing about this one here is if you compare it, so you can directly see that this one is bigger than this one, because this exponent 10 means just zeros. We have here 10 zeros and we have here 7 zeros, right? This is very nice to compare, so you can easily compare this kind of stuff. But with these long numbers, it's very hard. Let me jump here fast down. When you see, when I hover over it and you have here a long number like this, it's a little bit hard to compare easy. But these little numbers, you know, these are 7 zeros. And the other one has 10 zeros. 10 zeros will probably be bigger than this one. Yeah, it's much faster. That's just a side note. But let's go back to our let's go back to our questions. And the next thing is probably I will not make it too long because we talked already much, but we have to go a little bit more. Let's try the next question here. The next question is, it says here, 66, is try block a keyword? For what we need it? Explain the syntax and write an example code. All right, this one is also very big. Try it as good as you can, and I will go on, of course. So, is try block a keyword? The answer is simple. No, it's not a keyword. The try block is, like it says, it's a try block, but the keyword would be try. Try would be a keyword. Let's write in try is a keyword. Try is a key, word. This one is not a keyword, but the try is a keyword. Okay, then for what we need it. So what we need this try block to test. I write it very short, to test a code, because that's why it's called try. Try and test this code. And then I should, of course, write here one more thing, to test a code and react to the test. Because the test can be successful or it can fail, and then we have to react it accordingly. All right, let's go here a little bit more. Explain the syntax. We will go there and write an example code. Yes, we will go there. We start with this example code because, no, we start with the syntax because we want to use the syntax to write an example code, right? But before that, let's see the official answer for what we needed. So which means we have to jump to our try block. And when we go here to the try block, so let me show you how I come here first. Here's the try, because we have no try block keyword, but we have a try keyword try. I click on it. And here we have here two things to think about it. Here's a functional try block. We will not talk about this one. We skipped this one today. Instead, we are going for this normal try block. I call it normal because this is the very basic which you should understand first. Later, this one is with function, a little bit more complicated, but not too complicated, don't worry. But this one here, this is our try block. And you see, this is not really a syntax, but let's read this one here. Why we need a try block? It says here, associates one or more exception handlers with a compound statement. Okay, I don't know the answer, but it is absolute not that what I said here. I said here to test the code and reacts to the test. So what has this answer to do with this answer? This one is correct, definitely, because this is the official one. But when we read this one again a little bit more, it says here associates one or more exception handlers. All right, the exception handlers, we will talk about this catch clauses. These are just this one here, this catches here, and we can catch in many ways. So not only with one, careful, I mean not this different ways here. We can catch with 1, 2, 3, 5, 6 catch clauses later. And with a compound statement. Okay, again, what means this one? Associates one or more exception handlers, catch clause with a compound statement. Yes, this one is doing that, but actually when we watch it a little bit directly, the try block, first of all, the try block is here, try. First I try something. And what I really try is test a code, because that's the whole purpose of try. And after I test it, then I do exactly that what they say here on top. Then I associate it one with a catch, because if the try is successful, I don't do anything with a catch. If the try fails, which means we have an error, then I connect it with a catch. All right, so I hope you get this. This one is still correct, but I think my answer is also correct, because that's why we have the keyword try there. Okay, let's go on. We have, now I go to the syntax explanation, and when I explain the syntax, perhaps it makes then more clear. Let's go here. So we start again here with this one. This is the start syntax, and later we have here different variations, which only one is important. You can choose here which one you want, and depends on your needs, and perhaps you need all three. We will see. Let's start here with the try. You see again we have here try a black color. We need this keyword try. Yes, we need it. And here we have compound statement. What is a compound statement? I make it now very short. Of course you should read here statements. Here, no, this is expression. Here are statements, and you should read here what statements are, and you will see statements are more or less yeah, C++. It says here fragments of the C++ program that are executed in sequence, which means you can execute here code in sequence. For example, here declaration statements is here, expression statement, and if you are execute this one in sequence, then it is, yes, considered a statement as well. But yeah, read this one here a little bit through, but the most important thing is when we go to compound statements, and you can see a compound statement means it starts with the curly braces and ends with a curly braces, and all those other things are more or less optional, which means if you read, now that's why I make it a little bit short here, if you read again a compound statement, it means just curly braces, right? So here you can see this one, this open curly braces, closing curly braces, and like the syntax here with the compound statement, where was it here? This is the syntax here. Only important is this one and this one, and then you have to write your statements, of course, here, but you see optional, and you see this one is optional if you have more. But this one means compound statements. I think this one is important that you know this, because this comes over and over and over again. All right, we figured out we need just curly braces here. But important was this term compound statements, because you will see this here in the syntax almost all time. Here you can see here, 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 and it jumps all over the place. Okay, we have this one here. Then let's go to the next one. It says here handler sequence, and this handler sequence, you can see it's not declared here, but you can see the handler sequence is declared here, which means when handler sequence is a sequence, one of the handlers. So a handler sequence is one handler, and it can has this form, this form, this form. But what is a handler again? like I said in my answer here, we have here a try. We test code, and in this try block, right? So in this try block here, we will see a moment in an example, but here in this try block, we test a code, and if this code throws an exception, then this handler will catch it, which means it will react to our exception, thrown exception, and that means handler means just reacting. And then you can see we have here 3 options which we can use. The one means, I go not exactly now deep into this one. You can see again, catch is black, here the round brackets is needed, and all the other things we can use again. Here important is skip this one, attribute again, like all time optional. We are almost never use it. Then here type specifier sequence, that's very important, this type specifier, because later this type is deciding which catch we are taking. So this one is very important. Declarator is just the name. We talked about this one too. It's just the identifier. Not so important. That's interesting. First time a parameter name is not so important, because this one is important, and you will see later why. Then here the second one, the same like, let's here, I forgot this compound statement again, you can see, which means we need curly braces after this catch block again. Here an example, here's our catch, here's our clause, that was this one here, and this compound statement would be this one here. Nice example is here on the bottom, I think, for this one. That was the first one. The second one is here actually, here the second example, and you can see the only difference here, it's almost similar. The only difference is this one here. And if you read this one here a little bit, what this means, it means just unnamed formal parameter declaration. And here is an example. Here we have a name, that was our declarator. And here we have no name. You see, on the second one, we have just the type. And I said, this type here is very important. Here in this case, the name is not so important. But then we have a third option. We have not talked about this one, and we have not seen this much, I think, this ... This has, I think it has more meanings. In this case, it means just we can type, this catch block here will take any type. What it means, any type. For example, I said the type is very important because the try block will throw anything, an expression, and we talked about this one. Let me go here again. This throw, this try block will throw an expression. An expression is what? An expression is an exception object. An exception object is what? I said an exception object is an expression, but here, very important, it has a type and a value category, and the type is now very important here in our case because this catch block is reacting to a type. It will compare your try throw expression type with this type specifier, which is here. If they match, it will use it. Later I make this example when I explain it so in words. It's anyhow very strange to follow, but later when I explain it with an example, this will make absolute sense. So don't worry if you don't understand anything. Here it's important more that you understand this little words here, not how this works now. How this works we will talk later a little bit more in detail with the examples. But here I said this type specifier is very important, right? Type specifier is, for example, int or string or anything like that. And here, the last example is strange. I said this here, this ... means it accepts any type, which means I can use whatever I want, and this one will react as long as it is a type. For example, int, any int, if you have not these two blocks here, but you have just here, and it throws a int type, it will react. If you throw a string type, it will react. But if you throw anything which is not a type, this one can't react because it reacts only to types. And don't worry if you don't understand this one. And here is an example here, how we use it later. And so, with that said, let's see what we have here in try block. And okay, we have this one, explain the syntax, but now important so that you can really understand it, we make an example. So that I think we will not go too much on. It's very late already. But this example we will definitely make, and I will try to explain all this kind of stuff now with an example. But all time when you write an example, like I said, if you know the syntax already, then you can just write an example. If you don't know it, like me for example, then you just take this one here first. You copy this one, you go here, you go to this point, and then you use this one. But sometimes you don't know if it's usable in main, but you can start it. It will show later. So this was our throw. Let's see, I write this now here on top, a try block, and we will see it. So I use now the syntax. It says, okay, try is my keyword. Okay, try. Compound statement, we just learned it. It's just curly braces, the compound statement here. This curly braces are this one. I just copied this one. So I have this one here. Very nice. I paste it and you see I have it. But okay, this one is my try block. And my try block is here. And like I said, we will test here in this try block a code. But first I will follow the syntax. The syntax says, okay, I have finished this try. I have finished my compound statement, and now I have to jump to the handler sequence. And the handler sequence is specified, like I said before, is one of these options I can choose and depends on my needs. So I make first, let's use the first one here, and later we use more. We can use even all at the same time, but let's start slow, and later we go more and more in detail, and I show you all the other examples as well. So I use this one, which means I copy here as well the syntax, I paste it in and say, okay, after this one, it says I use a catch, because catch is a keyword, by the way. And then it says I have to use this round brackets, because when you watch this, these are black color here, which means use them. The gray colors, you have to declare your own, or to find, not declare, to find the real thing, what it is specified here. For example, in my case, so I have just to use this round brackets, and attribute is optional. In my case, I skip it. I don't need an attribute, most time not. But here, type specifier I have to use, and in this example I have to use the declarator, which is just a name. So I make a type, I make a very simple type here, which is very simple. Int, it's one of my primitive types, very easy. And a name, I call this one, you can call what you want. In my case, I call it, let's see, integer type param. And parameter, this one stays for parameter, param. Okay, and this one is already describing what the catch block will react. It will react to an integer type, and that's why I called it this one. And the next thing what I have to do is, it says here compound statement, again, just curly braces in our case, most time. Careful, not all time, but most time. And you see, we have done, and that was, by the way, our first example here. Careful, they use here this one. I will explain this later what this is. First of all, let's make our example. It's simpler than this one. This one is a little bit more complicated, but later I will explain this, but not in this video, probably in the next video, because we need much time for this. And yeah, first of all, I'm finished with my syntax. This is just the syntax, but it is not filled. And what is not filled? because the syntax is finished. We have filled all the syntax names here, terms. This is finished, but here in this compound statement, where it says compound statement, I have just filled in this curly braces, but I have not filled in statements, which means now what is doing this try block again? It is testing a code. So I have to find here a code which I want test. That's why we have here this try block. It says try this code. And let's write a testing code. For example, test my code, which is, I call it, for example, int my telephone number. And I declare it to this one here. Let's declare it to 1. And this test here is a little bit strange, but in a moment more. But this one is actually possible. Why is this possible? Because we can test it. But if this is throwing an exception is another story. And then here we can react. And this one will react to an int exception. What is an int exception? I will explain it not here because that will need also a little bit more explanation. But let's say this will react to an int exception, which means I write here, for example, std say out this reacts only for exception with type int. So this is my message here, which is later, like I said, we will discuss this a little bit later. Right now what I did is here just write an example code that was here our task. I will make it not too complicated, but let's see, it was here. Write an example code, and yes, I did it. The problem with this example code is that's bad, because if I start this one here, you can see, yeah, oh, this one is not that what I wanted. That was the other throw here, which means let's kick this one out. And yeah, let's test our star example code again. And yeah, it works anyhow, but is this tested or not? We can't see. And I need a better test for this one to show you. So I changed. This code is working, at least it seems so. This syntax is used, that's okay. But to demonstrate you now how a try catch block works, this example is very bad. I need a better example. And to make a better example, I have to throw here, for example, an exception. How I can throw here an exception? We learned this word throw. I can use this throw here directly below, and I can throw an exception. For example, I write here 1. And will this work or not? First of all, this syntax what I wrote here makes no sense, but interesting is this will work. And what will the output be? Do you think this one is the output? Let's see it. I started. Let's see it if it's work. Oh, indeed, it works. The question is now, okay, this one worked. This one is the output, but why? Why is this working with this one, and why, and what we are testing here actually? So, like I said before, this example what I made is bad. It shows nothing. Why this should be an error here. And to make an error, we have to write a context to that, and we say something like so. My telephone number is 1, right? And I write now here a comment. This telephone number must be all time 1 or it is an error. So this is my context, which I can't define because then I have to write a whole lot of code. And if I write here something like that, then I describe that this telephone number must stay 1. So, which means now what I can do is I say now if my telephone number is not 1, not equal 1, then I can say, okay, now if it is not 1, then we have an error, right? Per definition, I mean per definition here, per this here. Because I wrote this one here, I can write now this one here. Because I said this telephone number, which I declared here, must be all time 1. If this is anyhow not 1, which means it can be anything happens, right, during the code that this one was changed. I don't know how, because that's why it's so strange. I don't expect it that it should be changed, but anyhow it is changed. And then I will throw an error. And then I use this throw 1. Let's see, let's make here strange things happen. This is not a real code, but it simulates it. And I write here strange things happen, and my telephone number is assigned. For example, I take my telephone number, I assign it now. Anyhow, it is assigned, let's say this value here, and that's a problem. For example, there was a hacker, he got in my memory and assigned here a strange value and broke my code. So strange things happen. So this one is my strange thing. And now this test here should catch this strange thing, right? And now, when I start this one, let's see if this is working. Yes, it is working. It says here, I go here. This one is changed. Because this one is changed and not 1, I will throw an error and I will jump here because you have specified an integer type, which means here this one is an int, and my arrow which I throw, it's also an int. So that was a little bit better, not that much better as an example, because it's not a real world example, it's just a random as a fiction example. But I hope it makes a little bit clear. But we have still a problem. And the problem is, what means now this catches here? We have not talked about this catches here. Let's go here one step further. Let's say, let's keep this int. We know this one here is an int. You can see this is an int type. This int type will react to this int catch clause. That's why it's reacting. But what is if I have not here an int type? Let's say if I have here my coder. This one is definitely not an int type. When I hover it, you can see it says here concha. Let's say I start it here again. And it says here, it is again not handled. So my exception is not handled, which means it goes here, it tries this code again. It says this number, this telephone number should be 1, but anything, a strange thing happened and it becomes this value here. And then my check here, my check expect that this one should be 1, but it is not 1. If it's not 1, I will throw an exception, but this time I have another type, and the problem is this type is not here. And this is a string type or something like that, or in this case concha array, which can be converted to a string. But we as a starter have, for example, not covered this one, but we have learned here, we have learned here something like this line here. This third line says, I will accept any type and catch it. Let's make this. Okay, I have no clue what type this one is. Then I can write something like, let me copy this one here first. And I can put here another catch because I can put here many catches I want. But this time I change this one here. I accept any type. Any type. I will react to any type. Here we have the type. This one here we have a int type, which means this one will react, not this one, but this one is accepting anything. That's why we should use this one as the last catch block, because it's reacting just to anything. And in this case, let's write here, this will react to any type. All right, that's enough. This will react to any type. And if I start now, you can see, yes, this will react to any type, which means, which you can see, I have here again my try block, I have my check, and it throws this time error code of this const here, this const char, which is just a string, and this one says, okay, we have not defined a catch block specifically for string, but we have a catch block which can catch any type. All right, then let's go and see what happens with this. Now interesting is we have not made an example for that. Let's make an example for this one too. And you can see here one more thing here before I go on. You can see we have here int, but this int has here a name. And the name was this one here, the first version. You can see the first version. It says I have a type specifier and a name. Yes, I have this one. And I said in this version, it is not important to have a name. And here you can now see actually why it's not important to have a variable name here. Because, like I said, this catch here will only react for a type parameter, which means this catch is just checking more or less this type here. And here also, here you can put in any type, but here important is the type, not what happens here. And it will check the throw type, and checking throw type means it goes here to this coder, and when you hover it, this type here will be compared with this type here, and the other will compare with this type here, which means can be any type. And that's why the name here is absolutely not important. But another question, okay, we understand this name is not important, why we have it there? Because if you have a name, you get access to this type, and perhaps you can make something with that. Normally you don't want make with this name anything, because you just react to this one, and this one should be handled, which means you are not interested in the variable name to do something with that, because most time you can't perhaps you can't do something anymore because it's an exception, it's an error. And then you react on other ways. But it's a little bit strange to explain again, but I hope you get it, that only the type here is important, the name not. And that's why let's make this example here too. For this video, I think then I make a pause, and in the next video we go on, because there is much to talk about this one. But here, this example here, let's make here an example without a name. And let's write, I copy this one here again. And this time I make paste this one. And important to note is the problem is you can't not a problem, it is so defined, you can't use this one what I make here. And the reason for that is if you have already defined a int type, then it is already defined. You can't define two types who got ints here, because it is then considered to be handled with this int type. So it is not considered you can handle it with another int type. When I start here, for example, you see now we get a real error. This one is a real C++ error, not an exception. And you can see it here on the bottom. Here it says int is called by int on line 56 here, because here we have already int, and this one is also an int. And that means I can't use this one in this way, but I can use, for example, here, instead of an int, let's make them double. And you see, now I use the second syntax, which says I need just a type specifier and I can kick out the name. Exactly, I did this here. I write here just the type because only the type is important. And now I use here a double specifier. And how I can make a double? You can write a number. You can make a dot and a 0, for example. And when you to check it, just hover your mouse over it and you see the type is here double and the value is here 50. And this is also absolutely the perfect definition for an expression, right? We have a type and a value. Just here, expression again. This sentence is very important here. A type and a value category. So with that said, let's test this. This double, I have to change React exception with type double. And when I start now this one here, you can see this one is exactly here. This reacts only for exception with double. But there is much to talk about this. This was only some little basics, how we create this syntax, how we use the syntax, but the understanding of the syntax is not here. We have to, let's say, dive a little bit more deeper in this. I will. And of course with examples now, because now we have discovered the syntax and now we have to discover a little bit about these explanations, what this means, why it here's a const, why we can use here one catch or more catches, and why we can use here a throw, or what happens if we use a function. So there is much to talk. This was only the first video. There is one more video, and after this one we will cover many things. And I hope you followed so far. If not, don't worry, it's a little bit difficult for starters, but actually, if you followed at least a little bit, let's say this first here, try, catch, and that's it. Only one example of them. If you understand one example of them, so that you have to use a try, like this one here, for example, without this one here. You have just this try catch block. Here you test your code. Later you catch an error. But we have not talked enough about this throw, which we will a little bit more about this throw, what this is, where we can throw it, and how this one is more connected to this one. We have talked about this connection a little bit, that the type is here very important. But yeah, like I said, there is so much to talk. I hope I confused you not too much, but it's a start. And read this online, of course, again in a good C++ book. And then we will go on with our questions. And you see I covered here now only these 3 questions, but actually we are only talking now about this try block and this throw in the next video as well, because there is so much to talk. And after you understand this kind of stuff, that's very good. If not, don't worry. We will repeat it anyway. We will not understand all things because we have still not talked about classes, which is very important to explain other things. But still, it's good that we have not talked about classes, because then it becomes really more difficult. There are more things to consider, and you can already see here it's already difficult without taking classes in account. And yeah, that's why I will make classes more or less at the end of this tutorial. When we go to classes, then it's really hard a little bit on the other side, and on the other side it's really powerful and really cool. Okay, with that said, I stop here this video. And if you have any questions, any complaints, like all time, write it in the comments. If you have any tips and tricks, write this also in the comments, because that can help me and other people as well. And with that said, Good luck, don't give up. There comes one more video about this try catch block, but after that one you will at least understand the basics very good, because like I said, we have not talked about classes, and without classes we can't understand all things in detail, but we will understand many things, and the most important things, let's say, for starters. And yeah, good luck, don't give up, bye.